So, we have understood that in order to represent a point in the space using cylindrical coordinate systems, we need to have rho phi z. Since rho is the radius of the cylinder, it cannot be taken as the negative. So, that the range of the rho is from 0 to infinity, and phi is the angle measured from the xz plane in anticlockwise direction. It is about rotating, that means 360 degrees we can able to rotate. The range of phi is 0 to 2 pi, and z is similar to whatever the z we have seen in the rectangular coordinate system, same z. So, z is the distance. So, the range of z is from minus infinity to plus infinity. These are the ranges for rho phi z we have to consider. In case of two dimensional polar coordinates, if you consider like this x and y, and this is the point due to the phi value and rho value, this is the phi. Now, assume by fixing rho, phi 1 is the angle, the arc length is given by L1. Now, you change phi value by fixing the rho. So, phi 2. Now, the arc length is L2. We need differential lengths. This concept already I have explained, once again I am repeating that one. So, phi 1 leads to the arc length L1, phi 2 leads to arc length L2. That means, if you have the change in the coordinate phi, that means phi 2 minus phi 1, then what is the change you are getting in the arc lengths? That is the differential length. The differential length vector due to the change in phi, that is what I am going to explain. So, angle is equal to arc length by radius. According to that, we can write phi 1 is equal to L1 by rho, phi 2 is equal to L2 by rho. If you take the change in angle, that is d phi is equal to L2 minus, it is d phi is nothing but phi 2 minus phi 1. So, that you will be having L2 minus L1 by rho, that is dl by rho. So, differential length dl is equal to rho d phi. So, whenever angle is coming, whenever you are dealing with the angle difference, if you take the difference in angle, what is the difference in length is nothing but rho d phi we are getting here. That means, extra scaling factor we are getting. But in case of dx, that means if you change the x, dx, dl is the dx ax only, dy ay only will get, dl is equal to dy ay in case of the y, if you change in y direction, if you change in the z direction, dl is equal to dz az only will get. And if you change in rho direction, dl is equal to d rho a rho only will get. But if you change the phi, what is happening here? Not only we are getting d phi a phi, we are getting rho d phi a phi, that is the observation we have to make. And third one, that is dz, z is the distance, simply if you travel in z direction, dz is the differential length we will get. So, if you have change in rho, d rho a rho cap, if you have change in phi, rho d phi a phi cap, if you have change in z, dz az cap. Total differential length is d rho a rho plus d rho d phi a phi plus dz az, like that we will get. Now, surfaces, three surfaces we have, and ds rho is nothing but the differential surface in rho direction. ds phi is differential surface in phi direction, differential surface in z direction is given by dsz. For any surface, the direction of the surface is perpendicular to that one. Here already we have given the direction of this particular differential surface is rho direction. That means, a rho is perpendicular to that particular surface. That means, the surface is created because of the change in phi and change in z. Change in phi is leading to rho d phi, change in z is leading to dz. So, because of the changes in phi and z, you have created one surface. That surface is having the direction a rho direction. And in this particular case, the surface has been created because of the changes in rho, changes in z. That means, the surface direction is a phi direction. And then in this case, third case, ds z bar is due to the changes in rho, d rho, the changes in phi, rho d phi. If you multiply these two differential lengths, you will get the surface dsz. That surface has been created because of the changes in rho and changes in phi, and that surface direction is in the az direction, like that we are taking. And here we have three differential lengths d rho, rho d phi, dz. If you multiply these three differential lengths, you will be having the volume. So, dV is equal, differential volume is equal to d rho, rho d phi, dz. So, that rho we are writing here. So, in this manner we will be having the differential volume. The same thing you can able to observe in this particular diagram. So, rho is nothing but moving away from the z axis or origin. So, if you observe one thing, this is related to one particular rho value and this is related to another rho value, and this is the change you are getting due to the travelling in the arrow direction, that means d rho. Next we will see about the phi. This particular line has been created due to the angle phi. If you take another phi, you are moving away from the x axis. So, this is the line, first line, this is the second line. This first line is at an angle of phi from the positive x axis. Second line is at the angle of phi 2, that one we are taking as phi plus d phi, some change is there. That change is actually this is phi 1, this is phi 2, the change is given by phi 2 minus phi 1, and here we have taken phi 1 is phi and phi 2 is phi plus d phi. So, that is d phi you will get. Okay. So, due to this particular change, this is the rho d phi. We know how that rho is coming, already I have explained. So, due to the change in phi, whatever the differential length is there, that is the rho d phi. This is the rho d phi and this is d rho. Now, because of the change in height in the z direction, that is simple thing, from here to here, here we are observing, this is the change we are observing, that is dz. So, because of these three differential lengths d rho, rho d phi, dz, this volume has been created. Okay. Now, we will start another coordinate system, that is spherical coordinate system. So, we have seen 3-dimensional Cartesian coordinate system, cylindrical coordinate system, and these are used to represent the points in the space. Similar to those two, the spherical coordinate system is also used to represent the point in the space. So, we are dealing with space, that means here 3 coordinates are required in this particular spherical coordinate system also, and the point in the space is represented by the 3 coordinates here, that is r, theta, phi. R is the radius of the sphere, that means if I give the r value, that means if I take r is equal to some value like r is equal to constant 2 meters, then you can able to draw a sphere of radius 2 meters with the center at the origin. That means how much address you have for that particular point means, now the point is not available inside the sphere, outside the sphere, point is available on the sphere. But in order to create the sphere, remaining 2 coordinates are there, rho and phi. We have to take the full range of rho and full range of theta and full range of phi. Remaining 2 coordinates we have to take full range and we are fixing the r value, then that sphere has been created. So, here r is equal to constant, that is equal to 2 meters, and theta value fully we have to vary, phi value fully we have to vary, then you can able to draw a sphere. Then theta is equal to constant means you are varying the r value and you are varying the phi value. Then what you can able to draw means one conical surface you can able to draw. So, now the point is available on this particular conical surface. If I give this r and theta values both, only phi is varying. That means the sphere will be intersected by this particular conical surface. Then you will be leaving with one circle like this. Now, the point is available on that particular circular line. So, we are approaching to that particular point. Next, if I give the phi value without giving r and theta,